Hello everyone. Today we are going to discuss about the topic service reservoir. It is also called as distribution reservoir, which is used for storing the treated water and supplying for various purposes. It includes fire demand as well as during the repair or emergency conditions during the maintenance activities. The water which is stored in the reservoir can be utilized, and it also balance the water flow based on the hourly demand requirement. Okay, next, various functions of the reservoir are it balance the hourly variation of water flow, and as well as it provides a constant rate of water supply from a treatment unit, and as well as it reduces the cost of repair, maintenance and operation, and as well as it improves the efficiency of the water supply system, and it also helps to maintain a constant pressure in the distribution main. The pumping of water without, that is during a variation in the demand, the water can be supplied without affecting the requirements, and as well as the water can be supplied uninterruptedly during any emergency or during the breakdown of a pump or during fire demand. The water stored in this reservoir can be utilized. Next, the overall, due to the provision of this service reservoir, the size of a pumping main, pipeline as well as the treatment unit can be minimized. Okay, next, the storage capacity of a reservoir can be computed by finding the balancing storage between the supply and demand variation, and as well as a particular quantity of water which is allotted for breakdown storage and fire storage. During any fire accidents, the fire extinguished can be operated using the water stored for firefighting purpose, and during any issues in the pumping system as well as a breakage in the distribution system, the water stored in this storage reservoir can be utilized, and it can equalize as well as the balance the water supply system. Okay, the water required for this can be computed based on the supply and demand values. If in case the constant rate of supply, but the demand will be varying based on our requirement, the hourly usage will be varying from time to time. That is, during early morning we will be using more, and afternoon it will be less, and during evening time we will be using more amount of water. So, this variation can be balanced using this service reservoir. Okay, this quantity can be computed by two methods. One is mass curve method and another one is analytical tabulation method. Okay, the procedure for mass curve method, a graph, it is plotted between the total cumulative demand and supply along y axis, and the time period along x axis. It is the quantity may be in million liters per day. It is the quantity along y axis, and the time period along x axis. We will be getting this curve. It is cumulative supply, that is the supply is constant, and the demand, it will be varying. the excess amount of demand, that is the maximum ordinate, as well as the deficiency can be measured from the graph. This two values, the summation of these two values will provide the amount of water that need to be stored in the service reservoir. Okay, next, the same in case of analytical method, the data, that is hourly demand, is available from a data. Then we can compute the cumulative hourly demand as well as supply. Next, we can compute this two values and we can tabulate and find the excess demand as well as the hourly excess supply. These two values will provide the amount of water, that is the maximum value of excess supply and maximum value of excess demand will provide the amount of the water need to be stored, that is the storage capacity of the reservoir. Okay, now we will discuss a problem which is by analytical method. Here the water requirement for a different time period, it is provided in terms of million liters, that is for a time period of, that is from midnight 12 am to and 4 am, it is 0.48 million liters is the demand, and similarly for every 4 hours the demand requirement is given over here. And here the two different cases are given. The first case, it is about the water supply is done continuously for 24 hours, and in the second case the water supply, it is done only for a limited period of 16 hours. The 16-hour time period starts from morning 4 am. From 4 am the water is supplied continuously for 16 hours. Okay, based on these two cases, now we are going to compute the amount of water that is need to be stored in the tank. We can compute based on the demand and supply requirement. Okay, this is the table, this is the data time period which is given for us, and this is the quantity which is in terms of million liters, that is the amount of demand. From this the cumulative demand, it is computed from this values, that is the successive values are added together. That is the first one, it is the demand for a time period of 0 to 4 hours, it is 0.48, plus the demand next 4 hours, it is added together, will give a 1.35. Next 1.35 plus 1.33 will be getting 2.68. Along with this, if we add the next successive value, we will be getting 3.68. Next 0.82 will be getting 4.5. Next value is 0.54, we will be getting 5.04. It is the total amount of water which is required for entire 24 hours. From this total quantity, we can find the rate of pumping. The value divided by 24 will give the hourly requirement, it is around 0.21, which is multiplied by the time period 4 will give the value of 0.84. It is the demand which is required for each and every time duration is calculated over here. That is, as we mentioned here, it is a constant rate of supply for all 24 hours, around 0.21 million liters is supplied or it is pumped. Next, the cumulative pumping, it is addition of this successive values, the first one 0.84, and we are going to add the consecutive the values, and we will be getting the cumulative amount of pumping, that is it is also will be 5.04, it is the total amount of the pumping. Next, the excess of this demand, that is we are going to subtract the cumulative demand minus the cumulative pumping, that is for this three values, this is the excess value, that is 2.68, 3.68, 4.5, it is the excess amount of demand. So, we are subtracting the 2.68 minus 2.52, we will be getting 0.16, next 3.68 minus 3.36, 0.32, next 4.5 minus 4.4, 0.1, it is the excess demand. Next, the excess supply, it is the amount of, that is a value which is 0.84 minus 0.48, that is the excess amount of supply, that is the pumping will be more, demand will be less. So, 0.84 minus 0.48, and then 1.68 minus 1.35, we will be getting 0.33. From this, the excess demand, the highest value is 0.32, and in excess supply the highest value is 0.36. From the table, that is 0.32 million liters, it is the excess demand maximum, and 0.36 million liters, it is the excess of supply. The summation of these two values will provide the total amount of water required for this storage capacity. Okay, therefore, the next case, here the values similar, that is all the data, time and demand which is given is constant. The only variation is the pumping, it is different, that is the pumping, it is starting from 4 am. So, up to 4 am there is no pumping, so it is mentioned as 0, and continuously for 16 hours up to that is during the midnight, sorry, during 8 o'clock up to 8 o'clock, it is 16 hours. So, we have calculated the pumping quantity over here. Next, the from this pumping value, that is it is only done for a time period of 16 hours, the total quantity it is 5.04 million liters, and the pumping is done for 16 hours. So, for 1 hour it is around 0.315. So, if we multiply it by 4 hours, for each 4 hours it is around 1.26. So, it is the constant rate of supply for this time period. Okay, from this we are going to calculate the cumulative, as we calculated earlier, the same way the cumulative demand as well as cumulative supply we are going to calculate by adding the successive values of a demand or a supply. From this we are going to compute the excess demand as well as excess supply, the maximum value we are going to take it for the storage capacity requirement, that is the maximum, that is the difference between demand and supply, it is 0.48, and the maximum of the excess supply, that is 5.04 minus 4.5, it is 0.54. The cumulative of this, that is combined value of supply and demand, it is maximum demand is 0.48, maximum supply is 0.54. So, the storage requirement for this case it is 1.02. You can find the difference, that is in case of intermediate supply, that is the water is supplied for a minimum time period, the storage requirement is more, but in case of the previous case 1, the storage requirement is lesser in case of continuous supply. So, it is the difference between the supply for a continuous time period and supply for a minimum time period. Okay, thank you. With this we can end the session. Okay, we'll see you all in the next lecture.